Hello everyone, welcome to next video tutorial on the module 5 that is based on graph. In the previous class I have explained what is graph and how to represent the graph and different terminologies like directed graph, undirected graph, weighted graph, then multi-graph, and we have seen how to represent the graph by using adjacency list and adjacency matrix, and which is the better technique compared to these two. Then in today's class I am going to start with the graph traversal algorithm. Okay, these are very important concept as exam point of view. The first one, we have two types. One is breadth first search and the one is depth first search. First one, in short you can say BFS, that uses the queue for implementation. Similarly, the DFS, depth first search, uses stack for the implementation. Okay, now how it works: the BFS algorithm, we start from the beginning node, or you can say the root node. From the root node we visit all other nodes in the given uh, given tree. Okay, for example, in the given example we start with the node A, then we explore which all node adjacent to the node A, we visit it, then we go for the finding the adjacents of the given node, neighbors of the adjacent node. For example, if I take A, B and C are the adjacents of given node A, then after that we go for which all nodes are adjacent to B and C. So we keep on doing this until we reach the last node. Okay, how it works: by making use of step 1, initially we define the queue size of how many vertices are there in the graph. Second one, select any vertex as a starting point for traversal. For example, in the given graph I said I start from the vertex A, then A is the vertex which I visited at the beginning, so that insert this vertex into the queue. Then the next step, we visit all the adjacent vertices of the given vertex. Like now I have visited the A, which all the vertices are adjacent to A is to be visit now. Then adjacent to A is B and C. So B and C will be added into the queue. Then after that, after moving for the next node, we delete the node A in the step 4. Okay, we repeat. We keep on going for next node by deleting the previous node. So we have to repeat this step until the entire queue becomes empty. Then we last, how we traverse from in the queue. Based on that sequence we are going to draw the final graph traversal. Like in this example, go for the step 1, select the vertex A as the starting vertex. Here initially I have started with the vertex A, then A is the initial vertex, so add it to the queue. Okay, then in the step 2, visit all the adjacent vertices of A. Adjacent vertex of A is B, D and E, so add them into the queue, D, E, B. And earlier the new vertices are B, D, E, old one is A, so delete A from the queue, the new vertices are D, E, B. Then similarly, next adjacent vertex of A is uh, here I've taken D. Okay, now uh, which all vertices are adjacent to D? Already B and adjacent of D is E, which is already visited. Okay, which is already visited, so no need to visit again, so that I am taking it as nil, and delete D from the queue. Then what is left? E and B. So move for the next node. Out of the adjacent vertices of B, D, E, D is visited. Next is I can go for either B or E. Okay, then next time I visit the vertex E, which all nodes are adjacent to E is C and F, which are not visited earlier. So add them into the queue. Then after this, from V started, E is the old one, C and F is the new one. Delete the E from the queue. So earlier E is there. Now we deleted E from the queue. Okay. Then new nodes are C and F. Then which is the next in the queue? B. Visit all the adjacent vertices of B. Which all vertices are adjacent B? C and E already they are visited, so write it as nil. Delete B from the queue. Earlier B is there, now B is deleted. Which is the next vertex? Next vertex is C. So which all adjacent vertices are there for the C? G is there. So add that G into the Q and remove that old C from the Q. C is removed. Earlier C is there. Now C is deleted. The new G will be appeared here. Then after this, the next is uh, all the nodes are widgeted. Okay, widget all the adjacent vertices of F which are not widgeted means already all are widgeted. The delete F from the Q. F will be deleted. Similarly, no more nodes are there. G will be deleted. All are widgeted. Then final result is how we started from the traversal initially from A, which all adjacent vertices we got P, D, and E. So we draw the line. Then after that we go for the next node D. It is already adjacent vertex is already widgeted, so we are not drawn any line here. Then we go for the E node. For the E we have two adjacent vertices C and F that we have drawn. Then after that we have visited B vertex. No more already visited nodes are there. No lines here. Then we came for the C. Then we have uh, check for the last node G is visited. This is how the binary uh, breadth first search algorithm works. Is it like the BFS? Make it as BFS. So once again, I'm going to explain. We start from the node A, initially A, then like insert into the Q. The next one, adjacent vector of A is BDE. So A is older one, new is BDE. That will be kept here. Then after that, the next node here I have taken DEB. That is why I will take D now. So from D, no more vertex to be widget because already widgeted. So we have to delete that. What is left? E and B. From the E, then C and F is there. Delete that E, C and F to be added. For next is B. B already vertex are deleted, so remove it. Only keep C and F. Then for CF, C, which all adjacent vertex are C is there, G. So add that G into the Q. Keep on doing this. We came to the last position. This is how the BSF algorithm works. Next is depth first search. So difference between the BFS and DFS is here we start with the node A. Then each time I am going to visit a single node. Earlier I am visiting all other many nodes at the same time of each neighbors. But now I need to visit only one adjacent vertex of each node. Okay, like BFS here stack size will be defined for the number of vertices. Then we start from one vertex once and push into the stack. Earlier I've taken Q, now I required the stack. Then visit any one of the adjacent vertices. It is an important. Earlier we are taking all other adjacent vertices to be reach same time, but here only one node to be visit each time. Then when no more vertex is adjacent to the given node, that time we have to pop that element and come for the previous one. From that previous node we have to check for a new node. Okay, and we have to repeat these steps until all the nodes are visited. Okay, so here we start from the node A, which all adjacent vertices are there, B. So first time only one adjacent node. Initially A will be inserted into the stack. Next is B. Here B is there. For the B, which is the adjacent vertex, C. E and C are there. I am taking only one now. So C should be taken insert into the stack. Then after C, for the C, which is the adjacent vertex, G, F, E, I have to take only one. So I am writing E. Okay. Then next, visit any other adjacent vertex of E. After E, next is D and F is there. I am going to visit D. So push that D into the stack. Push one by one if it is new one. Then when you reach to the D, look at here. When you reach to D, no more vertex are no more adjacent vertex are new. So that we have to delete from that. So go for the backtrack method. So pop from the queue. Earlier D is there. Now we have to delete that D from the queue. We go for the E next. Okay. Again we search from the E. What is the new vertex which is not visited? F. So that visit it. Then add to the stack. Then similarly, next for the F, which is the adjacent vertex is G. So visit it. Okay, and to the stack. Then when all the vertices are visited, we started deleting one by one. So first we did G, then F, then E, then C, then B, then A, then none. Okay, it is to empty. Then at the end we represent the path. Initially we start from A, then we visit B, then C. From C, neighbor is E. From E, we visit D, but D, we would start deleting from here. Then from D, we visit F. Then from F, we visit G. This is how this will get execute. Okay, just go through that in the next video. In the next interaction class, I am going to solve the queries. Thank you.